Basic vectors. A vector is a mathematical object that represents a quantity that has both magnitude and direction. A vector can be represented in two ways, geometrically and algebraically. Geometrically, a vector can be represented as an arrow, where the length of the arrow represents the magnitude of the vector and the direction of the arrow represents the direction of the vector, as shown in the diagram. The length of the arrow is its magnitude, direction of the arrow is the direction of the vector. Algebraically, a vector can be represented as an ordered list of numbers. For example, vector A is 4, 5. Vector B is -2 and 3. Vectors can be added and subtracted, and they can also be multiplied by scalars known as numbers. These operations have geometric interpretations. For example, adding two vectors geometrically means placing the tail of one vector at the head of the other vector, and the sum vector is the vector that goes from the tail of the first vector to the head of the second vector. Adding and subtracting vectors. Adding two vectors is defined geometrically like this. Two vectors are vector A and vector B. C is the resulting vector of A plus B. Subtraction of one vector from another is equivalent to adding a negative vector. Here we have two vectors A and B, and we have to subtract B from A. So we will draw negative B. So resultant vector will be C equals A minus B. When vectors are represented as column vectors, adding and subtracting is as simple as adding or subtracting the x and y coordinates of the vectors. These are two vectors, vector A and vector B. So A plus B will be 2 plus 3 equals 5, -4 plus 2 equals -2. And subtraction is A minus B equals 2 minus 3 equals -1, -4 minus 2 equals -6. Magnitude of a vector. The magnitude of a vector is the length or size of the vector, regardless of its direction. It is also called the norm or length of the vector. The magnitude of a vector is calculated using the Pythagorean theorem. Given a vector V with components v1, v2, v3 up to vn, its magnitude is norm of V will be v1 square plus v2 square plus v3 square up to vn square and its whole square root. Here we have a vector PQ. Vector P is 5, 3 and its magnitude is 5 square plus 3 square and its square root, which is 5.830951895. It's a complete display of a calculator. Now rounding to 2 decimal places, it will be 5.83. Worked example: P equals 4, 5, Q equals -2 and 7. Find 2P plus Q. Multiply both components of P by 2. So 2P will be 2 times 4 is 8, 2 times 5 is 10. Add together 2P and Q by adding together corresponding terms. So 2P plus Q will be 8 minus 2 and 10 plus 7, which is 8 minus 2 is 6, 10 plus 7 is 17. Now find magnitude of P. This means magnitude of P The magnitude of a vector can be found using the formula vector equals x square plus y square and its square root. So magnitude of p will be 4 square plus 5 square and its square root, which is 6.40312 and so on. Now round to 3 significant figures. P equals 6.40.